Hi, my name is Avril Sauter and we're discussing CCNA Wireless. In this lesson, we're going to talk about how to configure the roaming attributes on the wireless LAN controller. Now, many of you might be familiar with the word roaming from your cellular phone, where you can roam anywhere in the country or you can roam overseas. It's a similar concept when we talk about wireless LANs, and sometimes this is referred also to as mobility, and it's the ability for a wireless client to move from one access point to another access point without noticing a disruption to their service. And so what happens here is I will be connected to one access point, and so I'll be authenticated and associated, and then I need to move to another access point, which means I need to re-authenticate and reassociate before I can start sending data. And I need to be able to do that so quickly that I won't notice a disruption in service. And where you'll notice the disruption in service is with real-time applications like voice and real-time video, whereas if it takes too long to re-establish the connection, start sending data, I'm going to notice some jitter. Now remember, when you roam between access points, they must have the same SSID. So when we talk about roaming, we're talking about moving between two access points, keeping the same SSID. Now in this illustration, we're talking about intra-control roaming. I have got two access points, both connected to the same controller. Now when the client first connected to the access point, it would have associated and authenticated with that access point, and so the wireless LAN controller already knows the MAC address and the IP address and security context, quality of service context that are associated with that client that's connected with that access point. So when I move to another access point connected in the same controller, that controller already has that information. So in this case, when I move across, I will send a reassociation message in it to the new access point, and the reassociation message includes the BSSID of my old access point, and that information is then forwarded to the wireless LAN controller. And all the wireless LAN controller needs to do is update its client table to say, oh, this client is now associated with a different access point. Now when I do inter-controller roaming, that means when my client reassociates with the access point, the wireless LAN controller needs to go back to my original wireless LAN controller, and they need to exchange information about the client. And that exchange may include security context information like keys, etc. Now you may be thinking that that new controller will include all the client information and the old wireless LAN controller will delete that client information, but that is not correct. Because these wireless LAN controllers are on different subnets, if I was to break communication with the first wireless LAN controller and have the second one do all the processing, what would have to happen is the client would have to change its IP address because the new wireless LAN controller is on a different subnet. And if it changed its IP address, then its TCP UDP sessions would come down, i.e. its service would be disrupted. So what I need to do is I need to make sure that the original wireless LAN controller continues to accept data for this client and then forwards it via a tunnel to the foreign wireless LAN controller, which will then send it to the client, that will then send it to the access point, which will then send it down to the client. Now if you're familiar with mobile IP, this might seem very familiar to you. Now, if you're familiar with mobile IP, this will sound very familiar to you. The original wireless LAN controller is what's referred to as the Anchor wireless LAN controller, and the new wireless LAN controller that I'm now connected through is called the Foreign wireless LAN controller. And in the diagram here you can see that I now have set up a tunnel to exchange information between them. Now there are different tunneling protocols. In the case of Cisco, they're using an Ethernet over IP tunnel. So effectively what happens is packets destined for this client will arrive at the Anchor wireless LAN controller, and it will say, oh, this is for client A, and so it will put a header on top of that packet and then send it on its way. That header will have the address of the foreign wireless LAN controller, and so it will go hop by hop across the network till it gets to the foreign wireless LAN controller. The wireless LAN controller will say, oh, this packet is for me. It'll take off that header, look inside the packet and say, oh, this is for the client, and then it would forward it to the access point, which then forwards it to the client. And in this way the client can keep the IP address as is moving between wireless LAN controllers. So I want to explain the concept of mobility domains and mobility groups. So a wireless LAN controller will belong to a mobility group, and it can only belong to one mobility group. A mobility domain can have multiple mobility groups within it. Now you can roam within a mobility group and across mobility groups, providing those mobility groups are within the same mobility domain. What I mean by that is if you move between mobility groups within the mobility domain, you'll still be able to keep your IP address, and the concept of an anchor and a foreign wireless LAN controller continue to exist. The reason why you have mobility groups, which are like a subset of the mobility domain, is that you may want to partition your wireless LAN controllers into groups, like, this one supports this floor, these ones support this building. And the difference between roaming within a mobility group and roaming between mobility groups within a mobility domain is when you roam between mobility groups within a mobility domain, you have to do a full authentication. And so you may want to separate out your wireless LAN controllers into different roaming mobility groups for security reasons. Now, you'll set up your wireless LAN controller and it will have your mobility group name, and you will add to that wireless LAN controller all of the other wireless LANs that are within that group. And then your wireless LAN controller will know to share information to those other wireless LAN controllers when the client roams within those supported access points. Now, the easiest way to understand this is to take a look at a demonstration. So let's go ahead now and connect to our wireless LAN controller GUI interface and set up a mobility group. Now I want to show you how you set up a mobility group in a wireless LAN controller. So here I am in my wireless LAN controller GUI and on the monitor screen, and what I'm going to do is I'm going to select controller, and the first thing I want to show you is, notice here my default mobility domain name. Now I would have set that up when I first brought up my wireless LAN controller, and I can change it here as well. So it's currently set to mobility group, and I'm going to leave that as is. I'm then going to select under the Mobility Management tab, Mobility Groups, and this is where I add the IP address and the MAC address of other wireless LAN controllers. And what I'm talking about here is the IP address of the management interface on that wireless LAN controller. And I do that by selecting New. Now, it's a good practice to make sure that you can reach the IP address of the other wireless LAN controller. So you typically come up here and ping it and make sure it's reachable. In this case, I'm just demonstrating the task of how to do it, and so you'd key it in here. The IP address, let's say, is 202, and here I'd put in the MAC address, and here I'm just going to make up the MAC address. Of an imaginary controller, and then I would click Apply. And now you can see that controller was added to my mobility group. Now the control and the data path is down, and that's because this isn't a real controller, but if I'd pinged it first to make sure it was reachable, I would have expected that to have been up if I'd had a controller on the network. Now, for every wireless LAN controller that you want to put in the mobility group, you have to add every other mobility controller on every wireless LAN controller. And you know, that could be painful if you were doing one after the other, and so it has this feature here called Edit All, and you can create a table in Notepad here with all of the IP addresses and the MAC addresses of the wireless LANs that you want in the mobility group, and you can just cut and paste it into here, and that makes it a lot quicker and a lot simpler for you to set it up. And again, you have to do this for every wireless LAN controller. Okay. And I have set up a group. That's it. Thank you. Now, to finish up our conversation on setting up mobility groups to enable roaming, I just want to remind you that there's several things that need to be the same, right? You need to make sure that the mobility domain name is the same. And if you remember from the demo, I just called mine mobility group, but that name needs to be the same on all the wireless LAN controllers. They need to be running the same code version, and the software release from 0.5 started to support up to 48 controllers to be in the mobility list. It needs to support the same LWAP mode, layer 2, layer 3, or the same CATWAP mode. The same access control lists if you have any, and then your wireless LAN SSIDs. You can't roam across if the SSID is not the same. And remember also the virtual interface IP address. And remember, on my controller I had that set to 1.1.1.1. It's not a routable IP address, but it is important in terms of roaming. So let's talk about a key term that you should be familiar with. The term mobility group. We've just finished discussing it, and a mobility group is a collection of wireless LAN controllers, and they share information about the clients that are connected to an access point and being managed by that controller. And by sharing that information between the controllers, it enables clients to roam between different access points that are being managed by different controllers, where those clients won't lose their IP connection, which means their session will stay up. So if they're watching a video or having a phone conversation or surfing the web, those connections will continue as they move between access points that are being managed by controllers in the same mobility group. I hope you've enjoyed this lesson.